M.S. Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment Analyze and Test Bistable Multivibrator. Aim of the experiment is to analyze and test bistable multivibrator circuit. Multivibrators are used as oscillators, flip-flops, and in the design of timing circuits like timers, delay circuits. They are also used in pulse modulation applications. Bistable multivibrator circuit has two stable states. An external trigger switches this circuit from one stable state to the other. Another trigger is needed to switch the circuit back to the old stable state. It is also called as flip-flop or binary circuit. It is a two-inverter circuit connected back-to-back. A bistable multivibrator can be used with commutating capacitors to speed up the transient response of the circuit. The apparatus required to conduct the experiment are DC regulated power supply, breadboard and designed resistors and capacitors, and multimeter. The circuit diagram for bistable multivibrator is as shown. The bistable multivibrator can be analyzed as follows. Calculated voltages at the base and collector of the transistors. In the following, the stable state considered is Q1 off and Q2 on. Notate the currents for transistor Q2 as I1 in RC and I2 in R1. Similarly, notate the currents for transistor Q1 as I3 in RC, R1 and I4 in R2. Corresponding voltages and currents are calculated as follows. Consider the currents in on transistor. VB1 is equal to VBB R1 by R1 plus R2. I1 is equal to VCC by RC. I2 is equal to minus VB1 by R1. IC2 is equal to I1 minus I2. Consider the currents in off transistor. I3 is equal to VCC by RC plus R1. I4 is equal to minus VBB by R2. VC1 is equal to VCC minus I3 RC. Finally, using VC2 nearly equal to 0, VB2 nearly equal to 0 for the on transistor, note that in practice, VC2 is the collector to emitter saturation voltage of SL100 and VB2 is the base to emitter saturation voltage of SL100. Output response of bistable multivibrator. Connect the circuit as shown in figure. Measure the voltages VB1, VB2, VC1 and VC2. Calculate the voltages VB1, VB2, VC1 and VC2. Observe which transistor is in on state and which is in off state. Apply negative triggering at the base of the on transistor and tabulate the voltages. The tables are as shown.
Hi students, the name of the experiment is Analyze and Test Bistable Multivibrator. The aim of this experiment is to test a multivibrator, namely the bistable multivibrator. The apparatus required for this experiment are DC power supply. It has two sources. This is switch on switch off button. Supply 1 positive negative, supply 2 positive negative. These two are used for voltage change. This is used for current change. This is used for coarse adjustment. This is for fine adjustment. In this experiment, we will use both the sources. Multimeters. It can be used as voltmeter or ammeter. If you use this knob in any position other than this is becoming on. Right now it is in off condition. If this is turned, it will be on. These are used for measuring currents. These are for AC voltage measurement. These are for DC voltage measurement. Resistance also can be measured in these ranges. To measure voltage or current in any circuit, we need these two terminals. One is the common terminal, the other one is to measure voltage or current or resistance. These two wires are connected with two probes like this, and these are used for measuring voltage or current or resistance in any circuit. In this experiment, we are using two multimeters as 2 voltmeters. Breadboard. This is a breadboard. Here on the top, starting from this edge to this edge, this represents one node. Again, starting from here to here, there is one more node. Like these two nodes, at the bottom of the breadboard, again we have two more nodes. Here and here, we have 5 dots representing one node. So 5 dots in one single column represent one connection. Again here 5 dots in one single column represent one connection. Transistors. This is the transistor used in this experiment. We use two such transistors. A BJT comprises of emitter, base and collector. To see the emitter, first you have to see where this notch is there, this small notch here. That adjacent terminal to the notch, this is emitter. Next base, next collector. Resistors. These are the resistors used in this experiment. These are 2.2 kilo ohm resistors, 2 in number. These are 15 kilo ohm resistors, 2 in number. These are 100 kilo ohm resistors, 2 in number. And connecting wires. These are used to connect the circuit using the components that are required. Now let us start connecting the circuit based on the circuit diagram. First take a breadboard. Take one SL100 transistor. First put the emitter to ground. Emitter to ground. So this line we will use for ground connection. Then take another SL100 transistor and connect the emitter to ground. So emitter is grounded. We will call this as transistor 1, this is transistor 2. Now put the collector of both the transistors one here and the other here. So two emitters are grounded, two collectors are placed, one here and here. So first collector, second collector. Take 2.2 kilo ohm resistors, 2.2 kilo ohm resistor. One you connect from first transistor collector to positive supply. So this line we will use for positive supply. Take another 2.2 kilo ohm resistor, connect from collector, second transistor collector to positive supply. So collector of second transistor to positive supply. Next, take 15 kilo ohm resistors, connect from collector to a nearby terminal. So 15 kilo ohm resistor. Again take another 15 kilo ohm resistor and connect from second transistor's collector to nearby terminal. So two 15 kilo ohm resistors from collectors to nearby terminals. Now take base of first transistor, and join to second transistor's 15 kilo ohm resistor. So this is base of first transistor connected to second transistor's 15 kilo ohm resistor. Similarly, take second transistor's base and connect it to first transistor's 15 kilo ohm resistor. So first transistor's base to second transistor's resistor, second transistor's base to first transistor's resistor. Now take 100 kilo ohm resistors, give from 15 kilo ohm resistors, both 15 kilo ohm resistors, give these two 100k resistors and join them together. So this is 100k, both are connected from both 15k resistors and they are connected together. This connection we will use for negative supply connection. So positive supply on the top, ground is at the bottom, and we will use this for negative supply connection. Now take connecting wires and connect from ground to supply of first transistor, negative terminal of first supply, negative terminal of first supply to ground. Take another connecting wire, connect from positive of first supply to positive supply of the circuit. So positive of first supply to positive of circuit, negative of first supply goes to ground. Take another connecting wire and connect from positive of second supply to ground. So positive of second supply to ground. Take another connecting wire, connect from negative of second supply to our negative supply. So negative of second supply to negative supply connection. Now take connecting wires, connect from collector of first transistor and leave it for connection of multimeter. Again take another connecting wire, connect from second transistor's collector. So second transistor's collector and leave it for the connection of multimeter. Next take another connecting wire and connect to the ground and leave it for connecting the multimeters. Now this wire and this wire will represent first transistor's collector voltage, these two will represent second transistor collector voltage. Now take a multimeter, connect positive of multimeter to first transistor's collector wire. negative of multimeter to ground. Take another multimeter. Connect positive of this multimeter to second transistor's collector. And connect the negative of multimeter to ground. Use another connecting wire if necessary. This completes the connections of the circuit. Now switch on the power supply and let's test for the output. Before switching on, make sure that the voltage knobs, these four, are in minimum and current knobs are in maximum. Now switch on the supply. Adjust 6 volts supply, 6 volts positive, 6 volts negative. So 6 volts positive, 6 volts negative. Now switch on this multimeter and put 20 DC volts. 20 DC volts. The value of voltage at collector 1 is shown as 5.26 volts. Now second multimeter switch on and put it in DC of 20. This is second collector's voltage. It is showing 0 volts. So first collector voltage is 5 and second collector voltage is 0. Now take a connecting wire, connect one edge in negative supply. Negative supply already we have connected here. So we will put this in the negative supply hole. So this is one edge connected to negative supply. Momentarily we will connect it for trigger. So right now this is first transistor which indicates off condition. This is second transistor which indicates on condition. So on transistor is Q2. So this negative supply wire that we use for trigger, touch it momentarily to on transistor's base. So this is on transistor base. This one, this is on transistor's base here. So we will touch this and remove. Now you can observe that first transistor voltage has now become 0 and second transistor's collector voltage is now 5.2. So hence on and off conditions have been reversed. This completes bistable multivibrator operation.
At MSR UAS, we spark your imagination unlike any other.